Imagine for a second that you are tasked with writing an 80-page, densely cited academic research paper.
Okay, sounds like a nightmare already.
Right. But there is a catch. You are not allowed to use any notebooks.
Oh, wow.
Yeah, you cannot use flashcards, you cannot open a blank document to jot down an outline, and you definitely cannot save any of your drafts.
So just doing it all in your head.
Exactly. You have to hold every single quote, every failed hypothesis, and every paragraph structure entirely in your short-term memory until the very last word is finished.
And if you lose your train of thought?
You basically crash. You have to start completely over from word one. It sounds completely impossible.
Because it is impossible for a human.
Well, welcome, learner, to today's deep dive, because that impossible scenario is essentially what we've been demanding from artificial intelligence for years.
Yeah, we really have. We assign these systems incredibly complex, long horizon tasks like building software from scratch, or, conducting extensive literature reviews.
Yeah.
And then we just force them to juggle every single step, every mistake, and partial result in their immediate cognitive workspace.
It is a fundamental bottleneck in how autonomous systems operate.
So today, our mission is to explore a state-of-the-art paper that introduces a new framework called InfiAgent. We are looking at how this system solves the frustrating reality of why supposedly brilliant AI agents suddenly forget what they are doing, get confused, or just, completely crash during massive projects.
It's a huge issue in the field right now.
Okay, let's unpack this. We are talking about a massive shift here, moving from context-based agents to file-centric agents.
Yeah, that's the core of it.
And to really appreciate how big of a shift this is, we have to look at the trap that current agents are stuck in.
Right. So the researchers define this trap as unbounded context growth.
Unbounded context growth.
Exactly. In traditional agent frameworks, the prompt itself is treated as the primary and often the only carrier of state. Everything goes into the prompt. To visualize this, it's like carrying an ever-growing stack of papers in your arms while trying to read the top page.
That is a great way to think about it.
Every time the model executes a tool or runs a web search or, generates a line of code, another piece of paper gets added to this stack.
And it gets heavier and heavier.
Right. Eventually the stack gets too heavy, you drop everything, or you just start confusing page 1 with page 100.
Yeah, and the technical reality behind that stack of papers is pretty severe. As the context window fills up with all those past actions and dialogue turns, developers are forced to rely on aggressive workarounds.
Just to keep the system from crashing.
Basically, yeah. They use truncation, which literally deletes the oldest memories, or summarization, which inherently causes information loss.
So it's forgetting things on purpose to save space.
Exactly. But even worse, leaving all that history in the prompt creates interference. The attention mechanisms of the model get distracted by irrelevant older tokens.
Which degrades its reasoning, right?
Yep. It degrades stability. The paper refers to this phenomenon as the illusion of state.
The illusion of state. So we think the AI is tracking the whole overarching project, but it's actually just drowning in the noise of its own short-term memory.
Precisely. It's just fighting to figure out what the next immediate step should be.
Wow.
It looks completely functional at the start of a task, but its performance curve drops off a cliff the fuller that context window gets. It is incredibly sensitive to early errors, too.
Like if it messes up early on?
Yeah, if it makes a mistake on step 2, the entire subsequent context is poisoned by that error, making recovery almost impossible over a long time horizon.
I mean, I get that, but I am struggling to see why this is still a foundational issue.
How so?
Well, we keep hearing about new models with, million token context windows. Or what about standard R setups?
Retrieval augmented generation.
Yeah. If I hook up a vector database to an agent, isn't it already storing data externally and solving this problem?
This raises an important question, and it actually highlights a critical misconception about how large language models process information.
Okay, I'm listening.
It is a matter of cognitive load versus data retrieval. Even if a model has a 2 million token context window, feeding all that long-term task state into the prompt means the agent still has to actively think about that entire history.
Just to decide what its next action should be.
Exactly. Every single step.
Oh, I see. Even if it can hold 1 million words, computing the attention weights across 1 million words just to figure out what to type next is a massive, unnecessary cognitive burden.
Right. And the researchers proved this isn't just theoretical. They conducted an ablation study.
What do?
They took their InfiAgent system, stripped away its unique memory architecture, and forced it to rely entirely on compressed long-context prompts. They essentially turned it back into a standard agent.
And what happened?
The performance completely collapsed. They ran it on an 80-paper literature review task, and the coverage for a 20 billion parameter model dropped to 3.2%.
3.2%. That is barely making it through 3 papers before entirely losing the plot.
It's terrible. And the variance was staggering, even for massive, highly capable models like Gemini 3 Flash.
Really? Even the giant models fail.
Yeah. When forced to rely purely on context windows, these giant models would randomly terminate early, skip crucial items, or just hallucinate summaries of titles instead of actually processing the text.
So building a bigger brain doesn't solve the problem if that brain is constantly overwhelmed by its own internal monologue.
Exactly. It's just too much noise.
So since we know forcing the AI to actively think about its entire history causes it to crash, the only way forward is to let it stop thinking about the past entirely.
Which brings us to the actual solution the paper proposes.
Right. Persistent state externalization. InfiAgent completely abandons the prompt as the source of truth, doesn't it?
It does. Instead, uses a dedicated file system like a literal workspace directory on a hard drive as the authoritative, persistent record of the task.
So the agent is no longer forced to remember, it is allowed to write things down.
Yes. And the true genius of this architecture is how it leverages a concept the researchers call zero-context compression.
Zero context compression. How does that work?
Well, InfiAgent strictly bounds the reasoning context at any given moment. It never tries to summarize the whole history.
Okay.
Instead, the agent only sees 2 things: a high-level snapshot of what is in its workspace and a fixed, rigid window of its most recent actions.
Like a history log.
Sort of.
Right.
But specifically, the parameter is set to cation $10. It only looks at its last 10 actions.
Wait, just 10 actions?
Just 10.
It doesn't matter if the agent has been running for 5 minutes or like 5 days or if it has taken 3,000 steps. Its immediate thinking space is just the direct retrieve its files and the literal 10 commands it just executed.
That's right. Decoupling the persistent state from the bounded reasoning context is what makes infinite runtimes possible.
Well, because the short-term memory is always clean.
Exactly. The file system stores all the complexity, the failed attempts, the partial code drafts, the raw data. This allows the reasoning engine itself to remain entirely clean and focused only on the immediate next decision.
I mean, I understand the theory of keeping the short-term memory clean, but I have a major logistical question here.
Sure.
If the AI is only looking at its last 10 steps and looking away to a file system for everything else, how does it actually execute a complex workflow without getting completely lost in its own files?
That's a very good point.
Like, what stops it from overwriting its own work or getting stuck in a loop of opening and closing the same documents?
Well, if you simply handed a standard, flat, multi-agent system a file directory, that is exactly what would happen.
Chaos, basically.
The researchers actually call it tool calling chaos. A flat structure lacks the authority to manage long-term dependencies.
So how do they fix it?
To solve this, InfiAgent doesn't just use files. It relies on a strict, tree-structured hierarchy. Technically, it is a directed acyclic graph, or DAG. Yeah. Mathematically, it enforces a one-way flow of execution commands. And in practice, this operates across 3 distinct levels of agents.
The DAG concept makes me think of like a highly rigid corporate structure. Let me see if this analogy tracks for you.
Let's hear it.
At the top of this hierarchy level 3, you have the alpha agent, the CEO.
Okay.
The alpha agent doesn't actually sit down and write code or read PDFs. It just looks at the user's overarching prompt, realizes what the big picture goal is, and delegates subtasks.
The corporate analogy tracks perfectly with how the node permissions work in the DAG, actually.
Really?
Yeah. The alpha agent, the CEO, delegates down to level 2, which consists of domain-specific agents.
The middle managers.
Exactly.
Yeah.
You might have a dedicated coder agent, a data collector agent, or a paper writer agent. They receive a specialized objective from the CEO and figure out the specific workflow required to achieve it.
And then those managers delegate down to level 1, right? The atomic action agents, the intern.
The interns, yes.
These are the highly specialized, narrow functions that actually touch the data. A web search tool, a Python execution environment, or a specific file reader.
And this strict parent-child control mechanism is what ensures stability. The nodes in the DAG restrict permissions.
So an intern agent cannot accidentally call a CEO-level planning function and rewrite the entire project roadmap.
Exactly. Higher-level agents invoke lower-level agents strictly as callable tools, enforcing serial execution with very clear boundaries.
Okay, the one-way flow of commands prevents the system from tripping over its own feet. That makes sense.
It does.
But let's go back to the heavy lifting. If the manager agent needs to process that massive 80-paper literature review we talked about, how does it actually get the information out of those PDFs without dragging all that text back into its clean-bounded context window?
That is handled by what the framework calls an external attention pipeline.
External attention pipeline.
Right. Let's say your manager-level agent needs to extract the methodology from a 50-page study. It absolutely does not load the PDF into its own prompt.
Thank goodness.
Instead, it calls a specific level 1 tool, such as answer from chaff.
So what happens inside that tool?
Think of it like bringing in an outside consultant for a single highly specific question.
Okay.
The answer from chaff tool spins up an entirely temporary, isolated LLM process. This isolated process is fed the document and the specific query.
So it's completely separate from the main project memory.
Yes. It processes the text, finds the answer, and then returns only that extracted answer back up to the manager agent.
And the temporary process.
The temporary process is then immediately terminated.
Oh, wow. That drastically changes the game. The main reasoning agent stays totally unburdened.
Yeah.
It just receives a 2-sentence summary of the methodology, while the temporary process handled all the cognitive load of parsing 50 pages of dense academic formatting.
It acts as an application layer attention head. It offloads the computational cost of reading entirely, protecting the main reasoning loop from being contaminated by massive token counts.
This architecture, the persistent file state, the rigid DAG hierarchy, the temporary attention pipelines, it all seems incredibly robust on paper.
It's very elegant.
But theory is one thing. I want to know how this architecture actually performs when you benchmark it against the trillion-parameter proprietary models that the massive tech companies are running.
Well, the benchmark numbers in the source material are where this paper makes its strongest statement.
Let's hear the numbers.
They evaluated InfiAgent using the Deep Research benchmark. It's a rigorous, standardized test for multi-step autonomous scientific research and data synthesis. Standard context-based models struggle immensely here.
And the numbers reveal a massive upset.
A huge upset.
The researchers achieved their primary results using just a 20 billion parameter open source model, specifically GP-DIROS 20B. And they did it with 0 task-specific fine-tuning.
Just out of the box.
Yeah. They just integrated this relatively tiny model into the InfiAgent file-centric framework, and it scored a 41.45 overall on the Deep Research benchmark.
What's fascinating here is the sheer efficiency of that score. To put that 41.45 into perspective, this 20 billion parameter model is operating on an efficiency frontier that competes directly with massive proprietary systems.
It's basically David versus Goliath.
It really is. It is going toe-to-toe with frameworks powered by OpenAI Deep Research, which uses a 200 billion parameter backbone, and Gemini 2.5 Pro, which operates at 128 billion parameters.
The 20B model, swinging way above its weight class.
Way above.
And it's doing this purely because it doesn't have to dedicate massive parameter weights to managing in-context attention over huge distances. It just uses its parameters for immediate reasoning.
Furthermore, if you break down the qualitative metrics, InfiAgent specifically dominated in instruction following and readability.
Because it doesn't forget the instructions.
Right. The explicit file-centric state and structured output control encourage strict adherence to the initial user instructions because those instructions aren't being pushed out of the context window by 10,000 lines of intermediate dialogue.
But standard benchmarks are just one data point. The real stress test was the long-term 80-paper literature review task we touched on earlier.
The one that crashes most systems.
Exactly. Reading the papers, writing summaries, and assigning relevance scores over hundreds and hundreds of execution steps. This is where the context-heavy baseline models completely fell apart, right?
Entirely. Standard models were failing to even hit 30 on the coverage metric. Claude Code averaged around 29.1 papers before giving up or crashing. Cursor scored a 1 up.
1.0. Yikes.
But when the researchers equipped InfiAgent with Claude 4.5 Sonnet, it hit a perfect 80.0 average.
A perfect score.
It read every single paper, completed every summary, and never crashed. Even the 20B open source model hit a coverage of 67.1.
That is wild.
It proves that explicitly externalizing persistent state is deeply correlated with stable execution over extended time horizons.
It's not just a marginal improvement. It's the difference between an AI that gives up halfway through the day and an AI that actually finishes the job. But the absolute aha moment for me was the real-world application case study. They built a concrete version of this framework called InfiHelper.
Yes, for end-to-end scientific discovery.
Right. Literature review, experiment synthesis, and manuscript drafting. It literally wrote full-length academic research papers from scratch.
And the evaluation of those papers is what makes this so compelling. They submitted these AI-generated manuscripts to a blind review panel.
Composed of real experts, right?
Right. Human experts with EI and IE conference experience.
They didn't tell the reviewers an AI wrote it, and the human experts judged the papers as having human-level quality.
Which is an incredible milestone.
They specifically highlighted the perfect logical coherence of the arguments and the flawless latex formatting.
Which points directly back to the DAG architecture we discussed.
How so?
Well, logical coherence is maintained across an 80-page document because the high-level outline is saved as a persistent file by the CEO agent, immune from being forgotten.
Ah, of course.
And the flawless formatting is achieved because the actual drafting isn't done by the main reasoning engine trying to remember syntax.
It's the intern.
Yes, it is executed by a specialized level 1 atomic agent that uses a strict, bounded tool just to compile the latex.
Having an autonomous agent that can literally fool IE conference reviewers into thinking it's a human academic is wild.
It really is.
But, as with all cutting-edge tech, every architectural choice has a cost. So what does this all mean for the listener who wants to use this tomorrow? What's the catch?
Well, the researchers are very transparent about the stark limitations. The first major trade-off is efficiency and latency.
It's slow.
Very. All of these deliberate structured actions take significant time. The file system operations, reading and writing to disk, periodic state consolidations to refresh the snapshot.
And passing messages up and down the DAG hierarchy.
Exactly. It all introduces heavy computational overhead.
It's the bureaucracy of that corporate structure. You have to wait for the intern to file the report, for the manager to review it, and for the CEO to approve it.
That's a perfect way to phrase it. Additionally, to ensure the state remains completely consistent within the workspace, the current architecture strictly enforces serial execution.
So it can only do one thing at a time.
Right. There's no parallel processing yet. So this framework is terrible for rapid, real-time dialogue or highly reactive environments.
So no real-time chatbots?
No. It is designed for asynchronous, knowledge-intensive workflows where latency isn't the primary metric.
I mean, waiting a few hours for a perfect literature review is a fair trade-off in my book.
True.
But there is a second limitation, the researchers point out, and to me this one is the actual danger. Hallucination propagation.
Yes, this is the inherent risk of externalizing state. Creating a perfectly organized file system doesn't magically make the underlying language model immune to hallucinations.
It just gives the model a perfect permanent memory of that hallucination.
Exactly.
And if you have a perfect permanent memory of a complete lie, the whole project is in trouble. Let's walk through how this cascades. Say a level 1 data collector agent is parsing a study, and it confidently hallucinates a fake statistic. It reads a p-value of 0.5, but writes down 0.001.
Which happens with LLMs.
Right. In a standard LLM, that hallucination might eventually just slide out of the context window and be forgotten. But in a file-centric system, it writes that fake statistic into a permanent CSV file on the hard drive.
And precisely because that file is treated as the undeniable authoritative record of truth for the entire project, every downstream agent is compromised.
The manager reads the CSV.
The manager agent writing the summary will read the CSV, assume the 0.001 p-value is an absolute fact, and the CEO agent will build its entire final conclusion upon it.
The error propagates permanently and structurally into the final deliverable.
It does.
It's a massive reminder for you, the learner, that even as we move toward these infinite horizon autonomous systems, you cannot just walk away completely. Human oversight, or an auditing mechanism, is still the ultimate safety net.
The silver lining is that separating the persistent state from the reasoning context makes auditing much easier.
Because you can just read the files.
Exactly. You can actually open the workspace directory and inspect the files step by step to find the error, which is vastly superior to trying to untangle a 100,000 token prompt to see where the model went wrong.
Oh, definitely.
But it absolutely requires an auditing mechanism in high-stakes settings.
To bring this all together, the paradigm shift we've explored today represents a fundamental evolution in how we build AI. We are moving away from context-heavy, bloated AI prompts that inevitably collapse under their own weight.
They do?
Instead, we are moving towards sleek, file-centric agents. By utilizing a strict directed acyclic graph hierarchy and externalizing their memory to a persistent workspace, these systems can achieve virtually infinite runtimes, taking on massive, multi-day projects without ever losing the plot.
And if we connect this to the bigger picture, treating persistent task state as a first-class object, totally separate from active reasoning, isn't just a fix for AI.
What is it then?
It's the blueprint for how humans and machines will co-manage massive knowledge bases in the future. It creates a shared, readable workspace where both human intelligence and artificial intelligence can collaborate transparently, looking at the exact same files.
And that shared workspace brings up a fascinating dynamic for our own future. Think about that hallucination propagation risk we just discussed. If infinite horizon systems like InfiAgent take over all the heavy lifting of execution, coding, and literature reviews, the human role shifts entirely. We transition from doing the work to auditing the agent's file system.
That's a profound shift.
So, the question for you to chew on today is this. As AI gets better and better at running the ultramarathon on its own, without ever dropping its stack of papers, are you prepared to become a full-time AI auditor, endlessly searching a digital workspace for that one confidently hallucinated file that could derail a 1,000-step project? It's a whole new kind of work. Thank you for joining us on this deep dive, learner. Keep questioning, keep exploring, and we will see you next time.